Alright, hey guys, Mr. Holly here. We're going to look at the problem set for lesson 2. Question number 1. You're playing a game that uses 2 spinners, much like the first example we did in the lesson. What you're looking for is to see if your result is less than or equal to 8, you win the game. So what you're going to do here is you're just going to go ahead and do your experiment. I'm not going to do it. I'm sorry, it's a product, so you're multiplying. So 1 times, like if you spun it and you got, I'll do 1 or 2 for you here. Spin it 4 times 5. Wow, big spin, first time, big spin. 4 times 5, product of 20. The goal is to have an answer that is less than or equal to 8. So I actually lost big, not won big. So you're going to go through that and you're going to write down all your products, answer some questions. What is the estimate of the probability of getting a product of 8 or less? So you would go through and you would look at all the times that you got a product of 8 or less. Okay, so you would just go through and record all of your answers that were 8 or less. Let's say you got 8 or less 5 times, then you would say 5 out of 15. Okay, that's assuming 5 times I got less than 8. I think it was less than or equal to 8. Alright, what's your estimate for the possibility of getting a product of more than 8? Well, if you got 8 or less 5 times and you got more than 8, 10 out of the 15 times. Okay, what is your estimate for the probability of getting a product of exactly 8? Well, you need to go through and you need to count and see how many times did I get exactly 8? Count. And then you would say, I got exactly 8 twice, or whatever, out of 15. So if you got exactly 8 twice, then you would put a 2 there out of 15. What's the most likely product? Well, you would go through and you would see which product occurred the most frequently. Play this game 15 times, we get the exact same results. The answer to that is absolutely not. This is based on our experiment. Okay, so the first one kind of depends on what you got whenever you attempted this. I did not perform the experiment, so my answers are different. You should have answers specific to your experiment here for number 1. Number 2, these answers are going to be the same for everybody. So, use the results from the survey to answer the following questions. How many students answered the survey? Let's look. We got 9, 6, 4, 5, and 2. So to figure out the total number of students, I'm just going to add these up. 10, 20, another 11 is 31 students. So I can see, this is just a frequency table. I'm just looking to see how many students answered each answer. Alright, how many students said that the snake was their favorite pet? I'm going to find snake. Looks like 5 students chose snake. 5. Now, what is your estimate for the probability of that student saying that a dog is his favorite pet? So let's think about probability. It's going to be the number of times we experienced it out of the number of times we, asked questions. So this is going to be out of 31 students surveyed, how many said dog was their favorite? The answer is 9. 9 out of 31. Gerbil, 2. So 2 out of 31. How many students said frog? Well, of the 31, none of them said frog, so the answer is 0. The probability is 0. Does that mean it is impossible for a frog to be someone's favorite pet? No, it's not impossible, but based on our experience, we find the probability to be 0. It's not true. It doesn't exist within our population. All right. A 7th grade student surveyed 25 students at her school. She asked them how many hours a week they spend playing a sport or game outdoors. The results are listed in the table below. Okay, so we've got a table, and we're going to use this frequency table to make a dot plot. 3 students said 0. 3 students said 1, or 4 students, excuse me, said 1. 5 students said 2. we're just putting whatever, as many as responded as 2, we're going to put that many dots. 3, 7 students responded with 3. So that's 7. 4, 3 students responded with 4. No students responded at 5. 2 responded with 6. None 7. And 1 student responded with 8. What is your estimate for the probability of that student answering 3 hours? Well, 1, 2, 3, 4, 5, 6, 7 students answered 3 hours. And that is out of how many students that were surveyed? Let's check. I'm going back up to the top and counting. 1, 2, 3, 13, 22, and 3 more. It's 25. It actually says in the question, 25 students. So it's 7 out of 25. What is your estimate for the probability of the student answering 8 hours? 1 student answered 8, so I would say 1 out of 25. What is your estimate for the probability of that student answering 6 or more? That is 6 and anything above 6. So 3 students answered a value that was 6 or more, so that's 3 out of 25. What is the estimate for the probability of the student answering 3 or fewer? Well, 7, 12, and then another 7, so 19 out of 25 answered 3 or fewer. F, if another 25 students were surveyed, do you think they would give the exact same results? No. If there are 200 students at the school, what is your estimate for the number of students who would say they play sports or games 3 hours per week? Well, I am saying that 7 out of 25 play sports or games 3 hours per week. If I wanted to scale that up to a population of 200 students, that would be increasing my survey size by a factor of 8. So I would increase my number of observations that were favorable by 8 as well and get 56 out of 200. So I believe 56 students play 3 hours. All right, looking at number 4, we are looking at the results of an experiment. In this experiment, a student flipped a spinner, and these were the results. Now, we were asked which spinner did they use. I think the best way for us to make a conclusion about this is to take the information here and maybe just put it in a table. So, if I were to look at this information, how many times do we land on 1? How many times do we land on 2? And how many times do we land on 3? Well, we landed on 1, 1, 2, 3, 4, 5, 6 times. We landed on 2, 1, 2, 3, 4, 5, 6 times. We landed on 3, 1, 2, 3 times. So it appears that 1 and 2 are more likely, equally likely, and more likely to be landed on than space 3. So, do we have a spinner where 1 and 2 are the same size, but 3 is smaller? Well, 1 and 2 are the same size here, but 3 is the same size as well. So not this one. On spinner B, 1 and 2 are the same size, and 3 is smaller, and that's what we're looking for. So I think spinner B looks good. And then on spinner C, 1 and 2 are smaller, and 3 is larger. 3 occurred less frequently, not more frequently, so we would assume that 3 is a smaller space, not a bigger space. So we can cross those out. It looks like B would be the most appropriate spinner for this experiment. All right. Hope that helps you guys. Keep working.